Hi guys, you got the revision booklet and we have to practice the course. You can see all the formulas are given to you. Chapter 9, chapter 10, chapter 11 and 12, that one. So these formulas are, you don't have to remember that thing, but those formulas are not given and you think still you need in your calculations. You should learn those formulas. Question number 1, if you can see here, what is work done? So it means they're asking work done here. Mass is given to you 20 kg and 10 meter. Now you need to remember that thing. We know the formula of work done is equal to force time distance. But if you see, force is in Newton, but it's kg. It means we are not using this formula. We are using, because work done is equal to energy is equal to mgh, which is equal to m. We have got 20. We have got gravity 9.8, because you can check in the formula sheet. That's given 9.8. And that is 10, and when you use calculator it will give you 1960 joules. Power is equal to work done divided by time. So work done we have got just now 1960, and time we have got 3, and if I use my calculator it should be 653.3 and watt, that one. His colleague holds a box placed using a force of 30 Newton. So we have force 30 Newton, work done, whilst box not moving. So if box not moving, there's nothing is happening. It means that thing when nothing is moving. So no movement. If I write down it for you, so remember that thing. So no movement means no work is done, of course. So it means that if we calculate, it means here work done is equal to, so work done is equal to 0 joules here. A 2000 watt motor uses 50,000 joules of chemical energy, and you need to use that thing. You need to use the time, because we know power, we just discussed power is equal to energy over time, or work done divided by time, but we need to find T. So T is equal to, we have got E over P. You need to make T as a subject, or you can use a quick triangle here. If we have E is equal to P times T, so you can easily understand that thing. If you want to find T, T is equal to E over P. Now I have got E is equal to 50,000 and P is equal to, given to you, 2000. And when you work this, I think was 25. Yes, so it should be 3 zeros and 3 zeros cancel. Yes, 25 seconds is the answer. Now next question, if you see that a machine is used to move other boxes, the machine has an efficiency of 55%. If it is supplied 900 joules, what's the useful energy output? I've already written the formula of energy efficiency, which is already given in your formula sheet. So now they're asking here useful energy. So it means useful energy is equal to, it means I say useful energy is equal to efficiency times input. So you have efficiency 55%, means 55 over 100. That means 0.55. So 0.55, and input we have got how much is given to you, 900 here. So when I use my calculator, I can write here, I want to save the space. So it is equal to 55 and 495 joules. So moving forward, what type of energy is wasted? Now, I'm sorry, you can see machine. So in machine we expect the friction, and friction always give you what, that is thermal energy. So it means you can say that thing either use can be it can be go for thermal energy, I'm sorry, so thermal energy, or it could be sound as well, because machine can make sound. Thermal energy or sound energy. So that will be the answer. Now next question here, How could I increase the efficiency of the machine? Now this is thing again, we discussed in the unit test. You see that thing. If we are talking the efficiency of the machine, so there are a few points which you need to know here. That either we say reducing friction. So I write here reducing friction, or we can say, I mean, if we can improve the design, still improve. Oh, sorry. The design. Oh, so I can write it here. I think it's not working. So reduce friction, improve design, or what else? It could be more than that. For example, we having a better material. We can use that one. These are the all, maybe reducing energy leakage like unwanted heat or sound, etc. We can do the thing. Now a salesman claims that a different machine has an efficiency of over 100%. State whether the claim is true or false. So first of all, I say, hopefully it is writing now. So false claim. Okay. Now I need to say, of course, it is impossible that any machine to have an efficiency of greater than 100. And why is it so? If I say, because I say, oh no, I don't want to write, I want to type it. So because that would mean it produces more useful energy, or not every energy, output than the total energy input. That should be the answer of this one. So we go for the next question. Describe the law of conservation. Again, we did this thing a lot, law of conservation of this thing. So law of conservation, the energy cannot be created or destroyed. It just transform. Just please ignore. So transform here. Now next one, what is energy conversion happening in the brakes when a car slows down? So I mean, when a car slows down, what do you think is happening? I mean, when a car slows down, it's already in kinetic energy. So it means we are talking about the kinetic energy already there. So kinetic energy is already there because car is moving. Okay, the car is moving. So when it slows down, so what do you think? What happened to that one? Kinetic energy slows down to what thing? Of course, because it's using the friction to slow down. So kinetic energy changes to thermal. I'm thinking, and sound as well. Sound energy. All right, so that should be the answer for this one. Now we next question we have got here, question number 6. Now we have got a diagram. They have A, B, C, D. You see this one is the highest one. That means the highest point, if you see here, this is the highest point, definitely is having the highest potential energy, because they'll say which point having the greatest potential energy is A straight away. What one is the greatest kinetic energy, which is the lowest one, which is B. All right, so it is B over here in that case. I mean, I hope you understand what I'm trying to say that thing, because at B point the gravitational potential energy is minimum, so that's what I'm saying is B, and at A point the kinetic energy is minimum, so of course A is the potential energy. Now describe the energy convergence between throughout the whole journey. So if you write the whole journey, so it means it's at the start you can see here the roller coaster has maximum, if the roller coaster say here, yeah, the maximum gravitational potential energy at A, of course, is downhill from A to B. So I can say, I can start writing here. So at the start, it has the maximum gravitational potential energy, and then and at A. Okay, then we can say here, as it moves downhill at point from A to B. So what happens? So A to B, what happens? GPE, our gravitational potential energy, is converted to kinetic energy, and so it means what happened? So the speed increases, and when you're going uphill again, B to C. So if you go to B to C, here we're talking about B to C. So what happened? Kinetic, not because, I mean B to C. So what happened? In that case, kinetic energy converts to what happened again to converts to GPE. So in this case, what will happen? Which is decrease, your speed decreases. So that happens in that case. We can write the comma here. And that's the cell. Now calculate the potential energy at point A. So we have to find the potential at point A. So at point A, if we can see, we have mgh. So we know potential energy is equal to mgh. So potential energy is equal to mgh. We have mass is equal to, we have got how much in that case? If we go for 500 kg, if you can see, is written here. So 500, and we are using 9.8, and because point A, the height should be here 140. So 140, and that will give you the answer. If I use my calculator, 700,000 joules. So that is the potential energy, we have got it. Now mechanical energy, so we know mechanical energy is equal to kinetic energy plus potential energy. So we have got already potential energy, which is kinetic energy should be 0 here, because if we talk in point A, so there's no kinetic energy, potential energy is maximum here. So it is equal to 0 plus what we have got, 700,000, and that will give me straight away 700,000 joules. Now calculate the kinetic energy at B. So when we talk about B here, so kinetic energy B is equal to, but my potential energy is 0. So kinetic energy is so my potential energy, so my mechanical energy is equal to kinetic energy plus potential energy. All right, and I want to know that thing. I need to find kinetic energy, which should be equal to my mechanical energy because my potential energy is 0. So my answer should be is equal to 700,000 joules. All right. Now calculate the velocity, and for velocity we have to come back to the formula, which is Ke is equal to half mv square. And I told you many times you have to know how to make the subject of this thing, but let's move to this thing. So we do over here. So Ke is equal to, have I missed anything? No. So we are doing G still. So so V square. So we have Ke is equal to, at this stage, same thing. What is 700,000? And is equal to 1/2 times 500 V square. And when you just do all the calculations, 0.5 and this thing, you should be getting 2800. So V is equal to under root 2800, which will give you somehow 53 meter per second. All right, so that's the thing, we have got it. But this is the V at point B given to you, right? Because the next question say at point C. So same thing, I will kinetic energy is equal to half mv square. So if kinetic energy half mv square, we are getting it. So we know that thing at C, if we have the point C here, we have potential energy maximum, kinetic energy is not there. So it means what happens here, so if I find the potential energy here, which is equal to mgh, and mass we have the same thing, 500, gravity we have 10, and height we have to have a look, what's the height there, it is 95. So I will use this 95 here, and which give me the calculation, wait, 500 times 5,000, and also it means 475,000 joules. But that's my potential energy. I'm looking for my velocity. So it means I think I know that the equation is, sorry, I'm using this space here. The total, the mechanical energy is equal to kinetic energy plus potential energy. And if I want to find my, for example, if I want to find kinetic energy, so my kinetic energy will be equal to mechanical energy minus potential energy. My mechanical energy from the last part, I got 700,000. Minus potential energy, I've got 475,000. So I will use my calculator to get what? So it is giving me 225,000 joules. So this is my kinetic energy. And I know the formula kinetic energy is equal to half mv square, and now we have 225,000 is equal to half mass, we will have the same 500, and v square. So v square is equal to, if I use calculator, will be 900 in my calculator. So v is equal to under root 900, and v is equal to 30 meter per second. There's a lot of things they have done it, but just try to go through and find the answer for that thing. I can explain in the class also. We are doing question number 7 now, because I just use the space, which is easy. Number 7 says here, winch I used to lift a barrel with weighing 750 Newton. Calculate the work done. So it's easy now. Work done is equal to force time distance. Force we have got here, how much? 750. And distance we have got here, how much is it? 2 meter. So of course, when you do 750 times 2, you know the answer should be equal to 1,500 joules. Now they're asking here, how does the work done by the winch compare the potential energy gained by the barrel? So it means if we see the work done by the winch is equal to the gravitational potential energy gained by the barrel, because if you assume no losses to friction or heat, so it means I can write here that work done is equal to potential energy which is equal to 1500 joules. So this is chapter 9. Just go through with it, ask me if you have any questions further, and I'll do chapter number 10 later.